Good morning, my dear students. This is Ashok, Chemistry faculty. Today I am explaining Chemical Bonding chapter 2026 January session JEE mains questions. The question is, identify the molecule X with maximum number of lone pairs of electrons obtained using Lewis dot structure among HNO3 and H2SO4 and NF3 and O3 molecules. Choose the correct bond angle made by the central atom of the molecule X. So HNO3 nitric acid we can represent in Lewis dot representation. We can make like this type of structure. See, in that oxygen atom has here 2 lone pairs, here 3 lone pairs, here 2 lone pairs. So that maximum number of lone pairs in HNO3 molecule is 1, 2, 3, 4, 5, 6, 7 lone pairs. 7 lone pairs present in HNO3 molecule nitric acid. Then come to the point of sulfuric acid H2SO4. If you see the structure of H2SO4, S double bond O, OH and OH. So the number of lone pairs on oxygen atom, 2 lone pairs, total 1, 2, 3, 4, 5, 6, 7, 8 lone pairs are there in this molecule. 8 lone pairs. Then in NF3 molecule, NF3 molecule, so here central atom nitrogen has 1 lone pair, the fluorine has, each fluorine has 3 lone pairs. Each fluorine has 3 lone pairs. In NF3 molecule we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lone pairs. This molecule has 10 lone pairs. Then we have O3, ozone molecule. In ozone molecule structure, if you observe, the lone pair electrons will represent like this. So here total lone pairs present is 1, 2, 3, 4, 5, 6 lone pairs are present in this molecule. So that out of these 4 molecules, which molecule having more number of lone pairs? NF3 molecule has more number of lone pairs. So now they are asking the question is, what is the bond angle made by the central atom of the molecule? In NF3 molecule the bond angle is 120 degrees. In NF3 molecule, nitrogen atom undergo sp3 hybridization. In that nitrogen atom has 1 lone pair, 3 bond pairs. Here lone pair, bond pair repulsions will arise. Lone pair, bond pair repulsions. Because of this lone pair, bond pair repulsions, the bond angle is decreases. Bond angle decreases. Bond angle decreases. So that the bond angle of NF3 molecule is 102 degrees. Originally sp3 hybridization containing molecule geometry is tetrahedral geometry. In tetrahedral geometry bond angle is 109 degrees 28 minutes. But here 1 lone pair is present. So because of presence of 1 lone pair, the bond angle decreases from 109.28 minutes to 102 degrees in NF3 molecule, because due to lone pair, bond pair repulsions. Because of this lone pair, bond pair repulsions, the bond angle will be decreases from 109 to 102. So the correct option is 102 degrees. Option 3 is the correct one. The next question is, which statements are not true about XeO2F2? A. It has seesaw shape. B. Xenon has 5 electron pairs in its valence shell in XeO2F2. C. The OXeO bond angle is close to 180 degrees. D. The FXEF bond angle is close to 180 degrees. E. Xenon has 16 valence electrons in XeO2F2. Choose the correct answer from the options given below. So once you observe the structure, xenon belongs to 18th group. The valence electron is 8 electrons. The valence electron is 8 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. It is bonded with 2 oxygens and 2 fluorines. With oxygen, xenon utilize 2 electrons with 1 oxygen. 2 electrons with 1 oxygen. Then with fluorine, 1 electron with fluorine, and this 1 electron with fluorine. So this belongs to one orbit, that is S. This is P, this is P, this is P, this is D. These 2 electrons present in one orbital. So total hybridization is what? sp3d hybridization with 1 lone pair. So what is the sp3d hybridization? Originally sp3d hybridization is what? Trigonal bipyramidal shape. Trigonal bipyramidal shape. Now 1 lone pair is there. That 1 lone pair present at equatorial position. Equatorial position. So oxygen atom present here and fluorine atom present here. Fluorine atom always present at axial position. That is more electronegative element present at axial position, less electronegative element present at equatorial position, and lone pairs also present at equatorial position. Because of this lone pair, the original sp3d shape is trigonal bipyramidal. Trigonal bipyramidal. Now this trigonal bipyramidal geometry is converted into seesaw structure. Because due to presence of this lone pair and bond pair repulsion, the original trigonal bipyramidal shape geometry converted into seesaw shape of the molecule. Seesaw shape of the molecule. So XeO2F2 shape of the molecule is seesaw shape. So A is correct representation. In this seesaw arrangement, xenon surrounded by 1, 2, 3, 4, 5, 6, 7. 7 electron pairs. 7 electron pairs in valence shell of xenon, but they given 5. So B is wrong. Then C is OXeO bond angle. OXeO. This bond angle is 120 degrees, but they given 180 degrees. This is also wrong. Then FXEF bond angle is close to 180 degrees. So actually this FXEF, this bond angle is very close to 180 degrees. So because of lone pair, exact 180 degrees is not present, but it is close to 180 degrees is present. That's why D is correct. So here xenon has 7 electron pairs. That means 14 electrons. One pair means 2 electrons. 7 pairs it has. So xenon surrounded by 14 electrons. But they given here xenon has 6 valence electrons in XeO2F2. This is also wrong. So that A and D are correct. The incorrect options, not true options, are B, C, E. So that option is, the correct answer is B, C, E. Because they are asking question which are not true. So B, C, E are not true. A and D are true. So the correct answer is first option, B, C, E. The next question is, given below are statements about some molecules or ions. Identify the correct statements. The dipole moment value of NF3 is higher than that of NH3. B. The dipole moment value of BH2 is 0. C. The bond order of O2F2 minus and F2 is same. D. The formal charge on the central atom of oxygen atom in ozone is -1. D. E. In NO2 all the 3 atoms satisfy the octet rule, hence it is very stable. Choose the correct answer from the options given below. First we will discuss about dipole moment. Dipole moment in NH3 molecule and NF3 molecule. In NF3 molecule, dipole moment. Next, NH3 molecule, dipole moment. So generally here dipole moment every dipole moment of the molecule depends on two, that is bond dipole and molecule dipole. So both are in same direction, dipole moment is more. Both are in opposite direction, dipole moment is less. So here the bond between nitrogen and fluorine is more electronegative than nitrogen. That's why this bond is moved towards fluorine atom side. This bond also move towards fluorine atom side. Then this bond also move towards fluorine atom side, but lone pairs will move towards upward direction. So the resultant dipole moment is opposite to that lone pair dipole moment. That's why the original dipole moment of the NF3 molecule is less, because the lone pair momentum and bond momentum both are not in same direction, both are in opposite direction. That's why the dipole moment will be decreases. But in NH3 molecule, nitrogen is more electronegative than hydrogen. That's why this NH bond momentum will move towards nitrogen side. This bond momentum also will move towards nitrogen side. This NH bond also will move towards nitrogen side, and the lone pair present on the nitrogen also will move upward direction. So that here the molecule momentum and bond momentum both are in same direction, so that the net dipole moment, the resultant dipole moment increases. So that here dipole moment is more because the molecule momentum and bond dipoles both are in same direction. So that original net dipole moment will be increases in NH3 molecule. So that NH3 has more dipole moment than NF3. So A is wrong option. Then B, that is BeH2. BeH2 molecule is linear molecule. In this bond momentum is moved towards hydrogen side. This bond momentum is moved towards hydrogen side. So that net momentum of beryllium is 0. So that dipole moment is 0. Dipole moment is 0. Dipole moment is 0. So in multi-atom molecules, dipole momentum depends on bond dipole moments and molecule dipole moment both. So that here bond dipoles, both bond dipoles are opposite to each other. So net momentum of the molecule will be 0. That's why dipole moment will be 0. Then in option C, the bond order of O2 2 minus and F2 is same. So here number of electrons and bond order. 14 electron molecule bond order is 3. 15 electrons bond order is 2.5. 16 electrons bond order is 2. 17 electrons bond order is 1.5. 18 electrons bond order is 1. Similarly here 13 electrons also bond order 2.5. 12 electrons also bond order 2. Then 11 electrons also bond order 1.5. 10 electrons also bond order 1. So now if you see that O2 2 minus, what is the number of electrons? One oxygen atom is 8 electrons. Two oxygen atoms are there. 8 plus 8 16. 8 plus 8 and 2 extra electrons are there. So total how many electrons we have? 18 electrons are there. So 18 electrons means bond order 1. Similarly, F2 molecule. Each fluorine atom has 9 electrons. 2 fluorine atoms are there. 9 plus 9, 18 electrons. So 18 electrons means bond order 1. So that these two are having bond order 1. Same bond order. So that option C also correct representation. Option B and option C are correct representations. The next point is the formal charge on the central oxygen atom of ozone is -1. So formal charge formula is number of valence electrons minus non-bonded electrons minus 1 by 2 into bonded electrons. So this is the formal charge formula. If you take ozone molecule, this is ozone molecule, Lewis representation of ozone molecule. So they're asking about central oxygen atom. This is central oxygen atom. So this is the in this central oxygen atom, what is the formal charge? Where number of valence electrons is equal to what? Group number. Group number. So that oxygen group number is 16th. The valence electron is 6. 6 minus non-bonded electrons. These are non-bonded electrons. These two are not involved in bond. So that 2 non-bonded electrons are there. Minus 1 by 2 into bonded electrons. This oxygen atom is surrounded by 3 bonds. 1, 2, 3. 3 2s are 6. So that 6 minus 2, 2 3s are minus 3. So that 6 minus 5 is equal to plus 1. So central oxygen atom charge is plus 1, but they given minus 1. So this is wrong. So D wrong and A wrong, B correct and C correct. Then go to that. In NO2 molecule, all the 3 atoms satisfy the octet rule. In NO2 molecule, nitrogen has 5 valence electrons. The 5 electrons will arrange like this. Here 1, 2, 3, 4, 5. It is bonded with 2 oxygens. Here 1 oxygen. Oxygen has 3 lone pairs. Here 1 oxygen. This oxygen atom also has 3 lone pairs. So total nitrogen is surrounded by how many electrons? 1, 2, 3, 4, 5. So here bond formation. This is bond. So this is bond. So we can write that NO2 molecule like this. What is the meaning of this bond is? This is day 2 bond. Here completely nitrogen given these 2 electrons to oxygen atom. So that here oxygen getting negative charge. Here nitrogen atom has 1 odd electron. 1 single electron is there. So here nitrogen oxygen atom has a normal neutral oxygen atom. This is negative oxygen atom. So this is the NO2 structure. In NO2 structure, nitrogen atom is surrounded by how many electrons? 1, 2, 3, 4, 5, 6, 7 electrons are there. Nitrogen atom surrounded by how many electrons? 7 electrons. So that this is what? Odd electron species. Odd electron species. But oxygen atom surrounded by 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen atom surrounded by 8 electrons. This oxygen atom also 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. But nitrogen atom surrounded by 7 electrons only. So in NO2 all the 3 atoms satisfy octet rule is wrong statement. So that what are the correct statements? B and C are correct statements. The next question is the pair of species among the following having same bond order as well as paramagnetic character will be O2 plus N2 minus, O2 minus N2 plus, O2 plus N2 minus, O2 minus N2 minus. So here we want to find out the number of electrons and bond order. Bond order. If in a molecule or species, if the number of electrons is 14 electrons, the bond order is 3. 15 electrons, the bond order is 2.5. 16 electrons, the bond order is 2. 17 electrons, the bond order is 1.5. This is 18 electrons, the bond order is 1. Similarly, 13 electron system also bond order 2.5. 12 electron system also bond order 2. Then 11 electron system also bond order 1.5. 10 electron system also having bond order 1. Now we check one by one. O2 plus. Originally oxygen atom has 8 atomic number 8. Number of electrons in one oxygen is 8. 2 oxygen atoms are there. 8 2s are 16. But positive charge is there, you remove 1 electron. If positive charge is there, you remove 1 electron. Negative charge is there, added an electron. So that if you remove 1 electron, 16 minus 1, 15 electron. This is 15 electron system. 15 electron system bond order is 2.5. Next, N2 2 minus. N2 2 minus. Nitrogen is valency containing 7 electrons. Atomic number 7. 7 2s are 14. 14 and add 2 electrons. 14 plus 2. 14 plus 2. 16 electrons. 16 electrons means bond order 2. Similarly, O2 minus. O2 minus. Oxygen 8 8. 16 minus 1. 17. Okay, now 16 plus 1. 17 electrons. 17 electrons means 1.5. Then N2 plus. In N2 plus, nitrogen atom has 7 electrons. 7 2s are 14. Positive charge means you remove 1 electron. 14 minus 1. 13 electrons. 13 electron means bond order 2.5. Then N2 minus. N2 minus. N2 minus. Nitrogen 7. 2 nitrogens are there. 7 2s are 14. 14 plus 1. 15 electrons. 15 electrons also bond order 2.5. Then O2 minus and N2 minus. Then N2 minus. So that now we will check that. First O2 plus N2 2 minus. We want the question having same bond order and paramagnetic character. So same bond order means, for example, O2 plus bond order how much? 2.5. N2 2 minus 2. So these two are not same bond order. Then O2 minus 1.5. N2 plus 2.5. These two are also not same bond order. Next O2 plus 2.5. Then N2 minus 2.5. These two are same bond order. Then O2 minus 1.5. N2 minus 2.5. So these two also not same bond order. So that the correct one is option 3. So both are O2 plus and N2 minus, both are having same bond order, that is 2.5. All these species are paramagnetic species. Paramagnetic species. Because the valency containing one unpaired electrons. Valence containing unpaired electrons. All these species are paramagnetic. Most of them odd electron species. 15 electron, 17 electron, 13 electron and 15 electron. Odd electron species. Odd electron species having paramagnetic character. And also 16 electron species also having paramagnetic character. The next question is, given below are two statements. Statement 1, the number of species among BF4 minus SiF4, XeF4 and SF4 that have unequal EF bond lengths is 2. There E is the central atom. Statement 2, among O2 minus, O2 2 minus and F2 and O2 plus molecules, O2 minus has the highest bond order. Then go to the first statement. Then first BF4 molecule, BF4 minus. So here boron belongs to third group element. So valence electrons 3. So one extra electron is there, that is also that. So that boron surrounded by how many fluorine atoms? 4 fluorine atoms it is bonded. So that 4 fluorine atoms, each fluorine contribute 1 electron for the bond formation. So that now these 2 electrons belong to one orbital, that is S, P, P, P. So that BF4 minus undergo sp3 hybridization. That's why this is what? Tetrahedral molecule. sp3 0 lone pairs. Tetrahedral arrangement. That's why this is BF4 molecule structure. Tetrahedral arrangement. In tetrahedral arrangement, all BF bond lengths are equal. Bond lengths are equal. Bond lengths are equal. So here boron atom symmetrically surrounded by all 4 fluorine atoms in tetrahedral shape. So that all BF bond lengths are equal. Next SiF4. So here central atom is silicon. Silicon belongs to 14th group element, 4th A group, that is valence electrons are 4, silicon valence electrons are 4. It is bonded with 4 fluorine atoms. Each fluorine contribute 1 electron, so that 2 electrons becomes 1 orbital, so that spp, so that SiF4 also undergo sp3 hybridization, 0 lone pair. That's why this is also shows tetrahedral arrangement. In tetrahedral arrangement of silicon tetrafluoride, all SiF bond lengths are same. Here silicon atom symmetrically surrounded by all fluorine atoms in tetrahedral manner. So all SiF bond lengths are same. Next, that molecule is XeF4 molecule. In that central atom is xenon. Xenon valence electrons are 8 electrons. 8 valence electrons is group number 18th group. So it is bonded with 4 fluorine atoms. 4 fluorine atoms, and also containing 2 lone pairs. So this is belongs to s orbital, p orbital, p orbital, p orbital, then d, d. So in XeF4 xenon undergo sp3 d2 hybridization containing 2 lone pairs. Originally sp3 d2 is octahedral. With 2 lone pairs, this octahedral geometry converted into square planar shape. So that XeF4 shape is square planar. In square planar shape, all XeF bond lengths are same. All 4 XeF bond lengths are same. Here xenon symmetrically surrounded by 4 fluorine atoms form square planar arrangement. So in this molecule also these XeF bond lengths are same. So that is equivalent bond lengths. Next, SF4 molecule. In SF4 molecule, central atom is sulfur. Sulfur belongs to 16th group. The valence electrons are 6 valence electrons. It is bonded with 4 fluorine atoms. 4 fluorine atoms. In these 4 fluorine atoms undergo, and 1 lone pair is there. This is S, P, P, P and D. So it will undergo sp3d hybridization with 1 lone pair. So originally sp3d hybridization is what? Trigonal bipyramidal. So with 1 lone pair, it will become seesaw arrangement. This is trigonal bipyramidal. Now 1 lone pair, the lone pair occupied at a equatorial position. So the remaining fluorine atoms will arrange 2 fluorine atoms at axial position. These 2 are axial positions, these 2 are equatorial positions. So equatorial. So here the axial SF bond length is different. Equatorial SF bond lengths are different. So that this SF4 molecule has seesaw arrangement, seesaw shape. In this, 2 different bond lengths are present. 2 different bond lengths are present. All SF bond lengths are not same. Axial bond lengths is different and equatorial bond lengths are different. Here SF axial bond length is more than SF equatorial bond length. So SF axial bond length is 164 picometers. SF equatorial bond length is 154 picometers. Axial is 164, equatorial is 154. That's why axial bond length is more than equatorial bond length. So SF4 molecule having 2 different bond lengths. So out of these 4 molecules, only SF4 molecule only containing unequal bond lengths. The remaining 3 molecules having same equal bond lengths, equivalent bond length. That's why statement 1 is wrong. In statement 2, the bond order O2 minus, then O2 2 minus, then F2, then O2 plus O2 minus the number of electrons and bond order. What are the number of electrons? 8, 8, 16, 1, 17 electrons. This is 18 electrons. This is 18 electrons. 15 electrons. 18 electrons bond order 1. Bond order 1. This is 1.5. O2 plus 15 electrons bond order is 2.5. So the highest bond order is O2 plus, but not O2 minus. They given O2 minus as the highest bond order. This is also wrong. So statement 1 wrong, statement 2 also wrong. So the correct option is first option. The next question is match list 1 and list 2 according to shape. So list 1 they given some molecule, that is XeO3, XeF2, XeO2F2, XeOF4. List 2 having BrF5, NH3, I3 minus and SF4. Out of this, what molecules having same shapes? So we want to find out the correct representation. In XeO3 molecule, xenon is the central atom. It containing 8 valence electrons. 8 valence electrons. It is surrounded by 3 oxygen atoms. Each oxygen utilizes 2 electrons. 2 electrons, 1 oxygen, and 1 lone pair is there. This is belongs to s orbital, p orbital, p orbital, p orbital. This is sp3 1 lone pair. So because of sp3 1 lone pair, it is having pyramidal shape. Pyramidal shape. Next, XeF2, same xenon, 8 valence electrons are there. It is bonded with 2 fluorine atoms. Each fluorine utilizes 1 electron. The remaining having lone pairs. Lone pairs, 2 electrons become 1 lone pair. This is s orbital, p, 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 and d. So this is sp3d, 3 lone pairs. Generally sp3d is trigonal bipyramidal with 3 lone pairs. All the lone pairs occupied, that is like this. This is trigonal bipyramidal. All the lone pairs occupied at a equatorial position. The remaining fluorine atoms present at axial positions. It's looking like linear shape, so that it has linear shape. Then XeO2F2, same like that, xenon, 8 valence electrons bonded with 2 oxygen atoms. Each oxygen utilizes 2 electrons for bond formation. Each fluorine utilizes 1 electron. Then 1 lone pair is there. So this is S, P, 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 D. So that sp3d 1 lone pair. sp3d 1 lone pair. sp3d is trigonal bipyramidal shape with 1 lone pair. It has seesaw arrangement. Seesaw arrangement. 1 lone pair is there. This is 1 lone pair. So seesaw arrangement. Seesaw arrangement, that is. Then XeOF4, same like that, xenon has 8 valence electrons. It is bonded with 1 oxygen, 4 fluorine atoms, 4 fluorine atoms, and 1 lone pair is there. That is S, P, 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 D, D. That is sp3d 1 lone pair. sp3d2 1 lone pair. So originally sp3d2 is octahedral, that is Xe like this. So here 1 oxygen atom is there, 1 oxygen atom and 1 lone pair. So that is remaining is fluorine atoms. So this is looking like square pyramidal. Square pyramidal. This is square pyramidal. Square pyramidal shape. Then BrF5, bromine atom belongs to 17th group. Valence electrons are 7 valence electrons. 7 valence electrons surrounded by 5 fluorine atoms. 5 fluorine atoms and 1 lone pair is there. So S, P, 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 D, D. So this is also sp3 D2 1 lone pair. So this is also what? square pyramidal. This is also square pyramid. Square pyramidal. Then NH3 nitrogen 5 valence electrons are there. It is bonded with 3 hydrogen atoms and 1 lone pair. So this is belongs to sp3 hybridization with 1 lone pair. sp3 1 lone pair. This is pyramidal shape. Pyramidal shape. Pyramidal shape. Then I3 minus also sp3d 3 lone pairs. That's why I3 minus also belongs to linear. SF4 molecule, sulfur atom belongs to 16th group elements, valence electrons is 6. It is bonded with 4 fluorine atoms and 1 lone pair is there. That is sp3d 1 lone pair. That is SF4 is sp3d 1 lone pair. Originally sp3d 1 lone pair is seesaw arrangement. So here XeF2 and I minus both are linear arrangements. XeF2 and I3 minus. Next XeO3 and NH3 both are pyramidal shape. Next XeOF4 and BrF5. So these two are XeOF4 and BrF5. These two are square pyramidal shape. Next XeO2F2 and SF4 both are seesaw arrangement. So these are the 4 different types of molecules. So here XeO3 and NH3 both are pyramidal shape. Then XeF2 and I3 minus both are linear shape. Next XeO2F2 and SF4 both are seesaw arrangement. Then XeOF4 and BrF5. So both are square pyramidal arrangement. So the correct answer is second option, that is XeO3 NH3 and XeF2 I3 minus, then XeO2 F2 SF4, XeOF4 BrF5. So second option is correct. So all of you understand well all these questions. Once practice these questions. So dear students, please subscribe my YouTube channel, click on the bell icon, and for daily JEE and NEET boosts. Thank you very much.